Hello everyone, in this video we're going to be discussing why Earth seems to be flat when in fact it is not. Imagine as if you were at the beach looking to the horizon and you see a straight line, right? Why is it not a curve? Why can't we see a curvature? That's what we're trying to answer, and we'll achieve that using math. We'll give a mathematical explanation as to why it seems to be a straight line when in fact it isn't. First of all, we're going to start with the scenario of a person at the beach looking in the distance. Imagine you're this person. There is a maximum distance you can see due towards curvature. This maximum distance can be defined as the tangency point of your line of sight with Earth's surface, which would be something like this: a straight line coming out of your eyes, touching the very maximum distance you can see, which is just the end point of the horizon from your perspective. Now a tangent line to a circle is perpendicular to one of its radius, so we've got a 90-degree angle here. Drawing a second radius connecting you to the center plus your height creates a right triangle. Since we know Earth's radius and also your height, we can get the distance from your eyes to the tangency point B, or the maximum point you can see. Let's call it L. By using the Pythagorean theorem, we know that your height plus Earth's radius squared is going to be equal to r squared plus L squared. Now rearranging the equation, we can get L, which is just what we wanted. We can also estimate the distance from your foot to the farthest point you can see in a straight line by creating another right triangle with hypotenuse L and sides D and H. Since we know your height and also L, we can find out what the length D is, once again using the Pythagorean theorem. Rearranging the equation for D and doing some algebraic manipulation, some terms cancel out, and then we're left with a nice equation for D, given by the square root of 2 times H times R. This is the estimated distance in a straight line from you to the farthest point you can see. Now why is it an estimated distance? Well, that's because we're considering a circle, so the real distance from you to P is an arc, not a straight line. For that, I'll create another equation using the angle theta formed between you, the center of the Earth, and the point P. Using the angle theta, we can then calculate the arc capital D, which is the real distance we're looking for. Now theta is just a fraction of the 360 degree or 2 pi radians of the full circumference. The same fraction is for the length of this circumference. The length of the circumference is given by the equation 2 pi times r. So using radians to simplify your calculations, we can say that theta in radians is a fraction of 2 pi radians, and taking the same fraction from the length of the circumference, we get capital D, which is the length of the arc we're looking for. The 2 pi's cancel off, and we're left with theta in radians times r. Now to determine theta, we start with one of the trigonometric functions. In this case, the chosen one will be cosine, since we know the Earth's radius and the hypotenuse firsthand, making it easier than using sine, since we'd have to calculate L first. Cosine of theta will then be r all over r plus h. And theta, which is what we want, will be the inverse of cosine, or just r cosine of r all over r plus h in radians. Plugging it into the equation for capital D finally gives us the answer for the real distance between you and point B. Now we're left with two equations, one for the straight line between you and P, and the other for the arc, or the real distance between you and the same point B. Let's plug some values into both equations and see what it spits out. We'll use 6.3 millimeters for the Earth's radius and 1.8 meters for your height, considering that you're at sea level, making no need to count your altitude into the calculations. For the estimated distance D in a straight line, we get approximately 4,791 meters, and for the real distance D, which is an arc, we get approximately the same 4,791 meters. What does that mean? Well, if the distance between two fixed points in a straight line and as an arc are approximately the same, then the arc is approximately a straight line. even though there still are differences between them, making the arc and the straight line not equal to one another. But these differences are so small on such a large scale that's not even noticeable. Hence, that's why Earth seems to be flat when we look to the horizon, let's say at the beach. The maximum distance we can see is so short that we can't even distinguish it from a straight line. That's why we see no curvature. Finally, we can see from the equations that the higher we go, the more the differences will show up in the results. And then, at a certain point, we'll be able to see Earth's curvature. Well, that's it for today. I hope you guys enjoyed this video and found it informative. Thank you for watching. See you later.